Okay, let's begin now our discussion of the cosine graph. And again, I'm just going to show you where it came from, going from the unit circle to now our other graph in the xy plane. And essentially x corresponds to time here. Okay, so say with any angle that we start in standard position here on the unit circle. Well, so at 0, in other words, I'm going to see where I'm at in terms of cosine. Well, again, I want to correlate these ideas in my mind, and we're just going to look at the quadrantal angles, but of course we could look at any of the angles as we went around in any locations. Okay, so remember that's an x comma y, which is cosine comma sine. Okay, so at 0, at time of 0 here, I'm at this location here, which is 1 comma 0. Well, if I'm looking at cosine here, now this graph below me, let's plot that point. Well, I'm going to look at what my x value is, or what my cosine value is at 0, and my cosine value at 0 is 1, so I'm going to go ahead and dot that in there. And then we're going to start this process of moving around the circle, right? But we're just going to look at the quadrantal angles as we go in this positive direction, right? Okay, so what's now our next location? Well, at pi halves here, what's my cosine value? Again, now I'm just looking at x or cosine value. Well, it's at 0. Okay. Let's keep on going, go on past there. So we're taking circular motion and we're going to then put it now on this new graph to show what that looks like over time. And when I get down here to pi, my x value or my cosine value is -1. So at pi I'm at -1. Keep going around to 3 pi halves. And what's my x value? 0. And then keep going here all the way back essentially to where I started, which would be 2 pi, 1 revolution. And that x value is 1 again. Okay, so again, let's kind of draw our shape. Again, it's sinusoidal in nature, so it's going to have this curvature associated with it. Okay. So after one period here, and I'm just going to kind of demark where we went after one period. And of course it would continue like this, and we could go on past there, or of course we could go into negative territory, do the same thing. But we just want to look at this one period for now. Okay, so remember, this horizontal distance of the time it takes to do one revolution, and I showed that here on the circle here. So we went around the circle and we came back to where we started there. We did one revolution. And so that one revolution, if we graphed it here in this xy plane with this x being time and y a function of time, then this cosine graph would look like this. Okay, and this is again my period, which was again 2 pi over the absolute value of b, which was just 2 pi over 1 because again, we just have a 1 in front of that x. So the period was 2 pi, the time it takes to do a complete revolution. And then again, my amplitude is this distance from here to here, the midpoint A, midpoint to the maximum, and that again is absolute value of A equals 1. Okay, so I just want to go through how we went from this circular motion to essentially this graph that we're seeing now, the cosine graph. And the cosine graph has the same sinusoidal shape as the sine graph. However, at 0 it starts at 1, whereas on the sine graph we started at 0, 0, didn't we? Okay, so that's the key thing we want to keep in mind, and let's look at now the cosine graph a little further. Okay guys, let's go ahead and look at, again, our parent function graphed here, y equals the cosine of x. So it's got a similar shape, it's sinusoidal in nature like the sine, but instead of starting at 0, 0 and say going upwards from there and then back down and back up to 0, it starts up at 1, it's going to go down through that dip, the trough there at pi, and then it'll come back up to 2 pi and end at 1. And I kind of extended my x-axis here because as we do this next problem, you're going to see why. Okay, so let's look at it. G of x equals 1/3 times the cosine of 1 half x. And I want to start by identifying a couple things. A, the absolute value of A is my amplitude. And that's going to be the absolute value of 1/3, which is 1/3. Then I want to identify maybe my period. Well, what was my definition? Let's write it. 2 pi over the absolute value of B. So 2 pi over the absolute value of 1/2. Remember, my B is found in front of the x. Okay, how do I deal with a fraction, say 2 pi over 1/2? Well, I need to flip it and multiply, don't I? Cancel. And that would be 4 pi. So notice my period on this function, instead of being 2 pi, is going to be 4 pi. So remember, when I go to construct these, I want to put that period in first. And since I already have the parent here, I'm going to try and do it in scale with the parent. So I'm going to come on out here to there, and let's call that 4 pi. Okay, and having the parent function already graphed has done some of the work for me. Because once I've, say, constructed that period length, I need to divide it in how many parts? Well, 4. So I would do 4 pi divided by 4. And I know my first location would be pi. But for me, I already have that. I'm just going to circle it because these are the locations I'm going to use. And then remember, whatever that is, say pi, I'm going to add that same amount to it to get my next location. Well, pi plus pi is 2 pi. Okay. And then, of course, I add pi to it again. And that would be here 3 pi. Okay, now I've got all of my locations on here. Okay, let me go ahead and erase and clear some space here. So, we found our amplitude, which is the absolute value of A, which is the 1/3, which is in front of the cosine of 1/2 x. Then I determined my period, which is, in this case, 2 pi over the absolute value of B, and remember, B is found in front of x. So I calculated that to be 4 pi. Then I put that 4 pi in there, and then what did I do? Well, I did 4 pi divided by 4 there, because I have to divide whatever that period length is in 4 parts. And so that gave me pi. So I know each section should be the length of pi. And then I did pi plus pi to find my next section. And then I did plus another pi to get my third section. And now I have my 4 locations that I'll use. Okay, so let me erase. Okay, so let's make an XY table. And let's do our values here. 0, pi, 2 pi, 3 pi, and then of course 4 pi. Okay, let's evaluate. G of 0. Well, that's going to be 1/3 times the cosine of 1/2 times 0. Okay, 0 times 1/2 is 0. Cosine of 0 times 1/3. Okay, what was the cosine of 0? Well, if we think back to my unit circle, if I'm at 0 there, well, my cosine value there is 1, isn't it? Okay, so 1 times 1/3, 1/3. Okay, let's maybe do g of pi. Well, what's 1/2 of pi? Pi halves. Well, what's the cosine of pi halves? Well, when I think up to a 90, what's my x value of a 90, or pi halves? Well, that would be 0, then times 1/2, 0. So knowledge of that unit circle is going to make this process just go a lot smoother. 2 pi, let me erase. Okay, g of 2 pi. 1/3 the cosine of 1/2 2 pi. 1/2 times 2 pi is the cosine of pi times 1/3. Okay, and then I think the cosine of pi, well, pi cosine corresponds to x. That would be a -1 times 1/3, -1/3. All right, g of 3 pi. 1/3 cosine of 1/2 times 3 pi goes in for x. Well, 3 pi times 1/2 is 3 pi halves. So the cosine of 3 pi halves, and then I think, oh, on the unit circle, 3 pi halves is a 270 down there at the bottom. That's 0 on x, so of course cosine corresponds to x. 0 times 1/2 equals 0. And then, of course, I want to do 4 pi too. Don't forget about that. Let me erase. Okay, and then let's do g of 4 pi, which would be 1/3 the cosine of 1/2 of 4 pi. Well, what's 1/2 of 4 pi? 2 pi. What's the cosine of 2 pi? In other words, when I come back right around to where I started, what was the cosine of 0 or else 2 pi? Well, if I think on the unit circle, that's going to be 1 for x and 0 on y, but I just want the x. 1 times 1/3, 1/3. Okay. So now I'm ready to graph. And I just want to plot my points, and then I want to think about my shape as a version of the parent, but of course with these transformations to it. Okay. And remember, the transformation here, if we have an amplitude of 1/3, that's a vertical stretch or shrink? Well, shrink, because my value is between 0 and 1, not greater than 1. All right, let's plot those points. Let's call that 1/3. Let's call that -1/3. Okay, at 0, I'm at 1/3. At pi, I'm at 0. At 2 pi, I'm at -1/3. And at 3 pi, I'm at 0. And back around to where I started, now I'm at 4 pi. 4 pi, I'm at 1/3. So notice now, my revolution didn't take, say, 2 pi to do a complete revolution. It took 4 pi. And then I'm going to try and sketch this as accurately as possible. Remembering I have a trough down here, and then it comes back up and it's got that shape. Okay, so it's got that same shape, although it's what? Horizontally stretched by a factor of 2. That's this 1/2. Horizontal stretch of 2. We're starting to see our transformations in here now a little more. Horizontal stretch of 2 and a vertical shrink of 1/3. So it shrunk it vertically and pulled it horizontally further out. It doubled its period. So the time it takes to do 1 revolution instead of doing 2 pi is 4 pi. Okay, so I hope these videos help you get started graphing y equals a sine b of x and y equals a cosine b of x. And we'll get into horizontal shifts, vertical shifts, and reflections in our next section. Okay, thank you.